This presentation is about the VTROX Advanced Robotic Vision System V9. The V9 is part of a ARV platform inspecting integrated circuits, metal parts, and hard disk drives. The V9 is a conformal coating inspection system used for presence, absence, and thickness. The V9 utilizes a collaborative robot that has a flexible multi-angle inspection capability. The vision engine is driven by the collaborative robot and allows us to inspect at any angle and any thickness angle. We use smart learning algorithms without CAD so that we can create the programs based on known good images. That process starts with 6 to 10 good boards. These are boards that have been qualified by your quality inspection group, meaning they have the proper coating in the proper place, the proper keep outs, and the correct thickness. We will inspect and learn these 6 to 10 boards, and then we will then add any side inspections necessary. By moving the vision engine on angle, we can inspect the side of tall components and pins. The next step is to do some fine-tuning, which would allow us to set our pass-fail thresholds. We'd go through a verification process where we're going to run a number of assemblies over and over that you would call debug. And then once debug is complete and our thresholds are set correctly, we would then be ready for production. So moving into the system, the graphical user interface is very easy and user-friendly. You'll see on the top left the process to learn the assembly would basically be the learn icon. You would load in your 10 assemblies board after board, and after each assembly runs it would learn that assembly and the features based on that being a past known good board. And then from there, after you complete the 10 boards, we'd go straight to inspection. And what we'd end up with is being able to review any potential defects that you might have so we can set our pass and fail thresholds accordingly. Typical defects that are capable with the V9i: excessive coating, overspray, orange peels, bubbles, insufficient, and of course thickness. One additional feature is looking for foreign material. This video shows the V9 in operation, going through the inspection process. You'll see that it moves across the field of view by carrying the vision engine on the collaborative robot. This video will show how the side inspection is utilized in the system. You'll see that you can program in any angle, in any direction, for the vision engine to be carried over the circuit card. After it inspects through this process, if you choose to use thickness measurement, it would drop the vision engine into a location to where it can inspect the vision engine. Typical coatings that are possible to be inspected with the V9. Then we move into how thickness measurement is accomplished. One of the important areas of measuring thickness is to confirm that you have the proper thickness and coverage for your assembly. So we use a laser with an interference displacement sensor that is going to measure the reflection that you get from the surfaces. So this confocal displacement sensor works this way. We use two different color lasers. There's a green laser that is going to reflect on the surface of the material, the conformal coating. That laser reflection is going to have a height measurement from the distance of that laser, as you see on the right. Then the second laser color is blue, and it's going to reflect on the board surface. So it's going to penetrate the coating and reflect on the board surface, and that reflection will set the bottom of the height. When those two values are combined, the distance between those two values become your height or your thickness. So on the left you'll see the sensor light. On the right you'll see the confocal sensor. As we move closer or further away, you'll see the different colors and different shapes that happen as these are brought closer and closer to the sensor. So as it compares to some other solutions with measuring thickness, one benefit that confocal displacement sensor has is that we can see and measure the top and bottom surfaces of materials by separating the light from both of those surfaces. So as you saw in the previous example, as the blue is transmitted to the circuit board, we can measure the blue. We know that it reflects at this height, and we then measure the green and know it reflects at this height, and the distance between those two measurements becomes our thickness in micron of the material. By using this white confocal displacement sensor, white light, it gives us higher resolution and allows us to see through shiny surfaces much easier than traditional laser displacement sensors. One additional benefit is that the confocal displacement sensor has a programmable focal spot so that it has a very small, narrow beam that allows us to get in between the gaps of components, like some chip capacitors and resistors. The specifications for the robot are here listed above. And I want to thank you for taking a quick tour of the Vitrox V9 conformal coating inspection system.